Hello everyone, welcome to the channel TopGate. In this video, I'll discuss solution to the critical section problem involving two processes. In the previous lecture, we have seen what is a critical section, as well as we have seen that in order to find a solution for the critical section problem, it should satisfy three requirements. Clear? So in this one, we'll see a solution to the critical section problem that is having only two processes. However, the aim is to find a solution for n number of processes, but slowly and gradually we'll move on to n number of processes. Right now we'll start with two number of processes, and then if we find a solution, a correct solution for two processes, then we can go for n number of processes. Okay, so in this one, we'll only assume that there are two processes, let's say P1 and P2. So we have only two processes, P1 and P2, and they both share the same critical region. Clear? So we should find a solution for both these processes, that when one process is executing in the critical section, the next process should not be allowed to execute in the critical section, and there should be a requirement of progress that should be satisfied. So before starting this solution, let's first try to understand what is the typical structure of a process PI. Because first of all, I'll tell you what is the structure of the process PI, and then in that structure format only, I'll write the code for process P1 and P2. So first one, typical structure of the process PI. So if we talk about PI, this PI process is divided into four sections. The first section is called as the entry section. Then the second section is the critical section. Then the third section is called as the exit section. And the fourth section is called as the remainder section. Out of these four, critical section we have already seen that what is the critical section. Now I'll tell you what is this entry, exit and remainder section. So if we talk about the entry section, that means if any time process PI wants to go to the critical section, then first it has to lock its critical section. What does that mean? That is, since we are trying to satisfy the very first requirement of mutual exclusion, that means if PI is executing in the critical section, then PJ should not be allowed into the critical section. That is why PI, before going into the critical section, it first has to lock the critical section. So all the locks will be provided in the entry section. That is, it will first ask the operating system that now I want to go to the critical section. If operating system allows this PI to go to the critical section, then PI will put a lock into the critical section in the entry section. Okay, after putting a lock in the entry section, now it will go on to the critical section, and after completing its work in the critical section, it will come out of the critical section, and the locks applied here in the entry section will be unlocked here in the exit section. Okay, so locks are applied here and then locks are released here. Clear? And remaining any other work will be performed in the remainder section. So in critical section, we are trying to access and manipulate the shared resource. In the remainder section, any other work will be done, like using the private resource or any other thing, whatever its requirement are, all those work except the work of the critical section will be done in the remainder section. And this remainder section is not necessarily at the end of the program. It can be anywhere in the program. So let's start the solution for process P1 and P2. So we have two processes P1 and P2, and they both share the same critical region. So let's assume one shared variable. Okay, so we have one shared variable, and let's call this shared variable as turn. So let's assume the value of this turn. So this turn can have two values, 1 or 2. So turn can have 1 also, turn can have 2 also. Apart from this, turn cannot have any other value. Now what does that mean? If turn is having the value as 1, that means it is now P1's turn to enter into the critical section, and if the value of turn is equal to 2, that means it is now P2's turn to enter into the critical section. Clear? So what process P1 will write to make sure that mutual exclusion and progress are met? Okay, so what code it will write? So first thing it will write, that we should have the entry section. So before going into the critical section, this P1 will write the entry section, will put the lock into the critical section. So let's assume it will write while turn is not equal to 1, do skip. Okay, so this is your entry section. Okay, after doing this, it will go to the critical section, and finally after completing its work in the critical section, it will come out of the critical section, and then it will write the code for exit section. So here it will write turn is equal to 2, and then finally it will go into the remainder section and terminate. So this is the code for P1. So now let's write the code for P2 also. So if we write the code for P2, the entry section of P2 will be while turn is not equal to, here we have written 1, here it will write 2, do skip. So this is the entry section of the process P2, and then it will go to the critical section, and after coming out of the critical section, it will write the code for the exit section. That is, here we can write turn is equal to 1, and then finally it will go to the remainder section and then terminate. Okay, now let's see how this is working and whether this solution is satisfying all those three requirements or not. So the first requirement is the mutual exclusion. So whether it is satisfied or not, let's see it. So initially I told you that the value of turn is equal to 1 or 2. It can have either value 1 or 2. So let's assume the value of turn is equal to 1 right now. Initially we have initialized this, the value of turn is equal to 1. So now let's see this. So what P1 will do, it will write while turn is not equal to 1, do skip. So it will check whether the value of turn is equal to 1 or not. If the value of turn is not equal to 1, then it will continue skipping and it will be stuck in the while loop. Okay, but the value of turn is equal to 1 right now. Therefore, this while loop will be broken and this instruction pointer will shift and it will now execute into the critical section. After completing its work in the critical section, it will come out of the critical section, and in the exit section it will write turn is equal to 2. So now the value of turn is equal to 2 and it will go into the remainder section and then terminate. Clear? Now the value of turn is equal to 2. At this moment P2 is willing to go to the critical section. So what code it will write? It will write while turn is not equal to 2, do skip. That is, the value of turn, if it is not 2, then it will be stuck in the while loop. It will continue to skip. But the value of turn is equal to 2 right now. Therefore, this while loop will be broken and it will go to the critical section and it will start executing into the critical section, and finally after completing its work into the critical section, it will come out of the critical section, and in the exit section it will write turn is equal to 1. That is, the new value of turn is equal to 1 right now, and then it will go to the remainder section and terminate. Now that was the serial order. That is, P1 was willing to go to the critical section at the first position and P2 was willing to go to the critical section at the second position. So there was no problem. Now let's see that P1 and P2, they are trying to go to the critical section at the same time. So initially we have the value of turn is equal to 1 right now, and P1 will write while turn is not equal to 1, do skip. So value of turn is equal to 1, therefore this while loop will be broken and it will go to the critical section. Now suppose P1 is working in the critical section. At that moment P2 comes. Okay, P2 comes and it also wants to go to the critical section. Okay, so what it will write? It will write while turn is not equal to 2, do skip, and the value of turn is still 1. Clear? So value of turn is not equal to 2, therefore this P2 will continue to skip in the while loop. It will be stuck in the while loop. Clear? So it will continue here. It will not be able to go to the critical section. Why? Because P1 is still working into the critical section. Now after completing its work in the critical section, P1 will come out of the critical section and it will write turn is equal to 2. Okay, so it will update the value of turn. Now turn is equal to 2. As soon as it does turn is equal to 2, this P2 who was stuck in the while loop, it will find that the value of turn is now 2. Therefore, this while loop will be broken and it will go to the critical section and it will do its work in the critical section. So we can see that mutual exclusion is satisfied. When P1 is working in the critical section, P2 is not able to go. And when P2 is working in the critical section, P1 is not able to go. Okay, so we can say that the mutual exclusion is satisfied in this case. Now let's talk about the second requirement, the requirement of progress. Okay, so in progress, we know, suppose initially the value of turn is equal to 1. Okay, and initially P1 is not willing to go to the critical section. Clear? P2 is willing. The value of turn is equal to 1 and P2 is willing to go to the critical section and P1 is not willing to go to the critical section at this moment. In the future, it may require its critical section, but right now it is not willing to go to the critical section. So what will happen? P2 is willing, P1 is not willing. So first code will be run by P2. So what P2 will write? It will write, while turn is not equal to 2, do skip. And what is the value of turn right now? The value of turn is equal to 1 right now, and it is finding the value of turn as not equal to 2. Therefore, it will be stuck in the while loop. It will not be able to go to the critical section. Clear? So it will not be able to go to the critical section unless and until there is an intervention of P1. That is, P1 should come and it will execute in the critical section, and then after coming out of the critical section, it will make the value of turn is equal to 2. As soon as it does this, the P2 will be allowed to go to the critical section. So indirectly, P1, who is not willing to go to the critical section, is taking part in the decision making process of who will enter the critical section next. Okay, so this should not be done. Therefore, progress requirement in this solution is not satisfied. You can take this another way. Suppose the value of turn is equal to 2 initially. Okay, and P2 is not willing to go to the critical section right now. P1 is willing. So P1 will write, while turn is not equal to 1, do skip. And the value of turn is equal to 2 right now. Therefore, it is not finding the value of turn is equal to 1. Finally, it will continue to skip in the while loop. It will be stuck in the while loop. It will not be able to go to the critical section. Why? Because the value of turn is equal to 2. So eventually this process P1 also has to wait for P2 to come to the critical section, make the value of turn is equal to 1, then only it will be able to go to the critical section. So indirectly P2 is involved, who is not willing to go to the critical section in the decision making process of who will enter the critical section next. Therefore, in this one also, progress requirement is not satisfied. So I told you that these two are the mandatory requirements which should be satisfied in every solution. So out of these two, this progress is not satisfied, hence this solution is an incorrect solution. Clear? So in the next video, we'll go for another solution and we'll try to find out that whether we can have any solution in which both these requirements can be met or not. Okay, thank you so much.